right heading wave optics. We'll see the interference part first. Superposition or interference, right heading interference. 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 All right. So what is interference or what is superposition principle? Just imagine you have two waves. Y1 is equal to A sine omega t. Y2 is equal to B sine omega t plus phi. Right. We got two waves here. Now superposition means what? Joining of two waves, right? Light plus light can lead to darkness. Have you heard the statement? Sound plus sound can produce no sound. You just imagine sound is coming from a speaker, another speaker, they are falling on each other, and at some positions if you sit, you won't hear anything because there can be destructive superposition of sound waves. Now what's happening in that case? We have a crust and a trough for this, and we have a trough and a crust for this. This is called crust, this is called trough. The portion that rises above is called crust, and the portion that is below the mean position is called trough. So this is crust and this is trough. And when two waves join together in such a way that the crust and trough fall on each other, what will happen? There is destruction because crust is cancelling trough. There is destruction. This is called destructive superposition. You can even have constructive superposition. What if they are in phase like this? Look at this. These are constructively superposing because crust is falling on crust. So there can be two cases, crust falling on crust and crust falling on trough. So crust falling on crust means it is constructive superposition. You will have a greater amplitude for the resultant wave. Look at that. This is one wave, this is second wave. They are falling on each other or they are superimposing. That is how we technically call it. Okay. And in such a case, we will have a wave whose amplitude is the sum of the amplitudes of these two. Look at this. If y1 is the height here, y2 is the height here, then this height at the same location will be what? Y1 plus y2. Now that is valid for any point. You take this point and this point has zero displacement, that is on the x-axis. This one also has zero displacement. 0 plus 0, you expect 0. Yes, right at the same location it is 0. Understood? Or if this is y1 at this point, at the same distance it is y2, then this distance will be what? y1 plus y2. So this is called constructive superposition. What is destructive superposition? Crust of a wave falls on trough of another wave. Crust and trough join together, right? And that is called destructive superposition. So waves can join together either constructively or destructively. Understood? This is why I said in the beginning that the light and light can lead to darkness. When light falls on light, there can be darkness. When sound and sound join together, there can be no sound. That is why sound engineering has so much of importance, right? While designing cinema halls, they take all these things into consideration. They'll place the speakers at certain positions. Otherwise, what happens? Sound from a speaker comes this way, another speaker comes this way. There are chances that they may fall on each other, and there can be distraction, which means what? You won't hear anything at certain locations inside the hall. Understood? So this is the basic idea of construction and destruction. And like I said, I've taken two waves here. Y1 is equal to A sine omega t. Y2 is equal to B sine omega t plus phi. Now what is this? A sine omega t. A is the amplitude of the first wave. Amplitude means what? Amplitude means the maximum height. The maximum height. Amplitude is maximum height. Similarly, for the second one, the amplitude is what? That is B. Look at that. The amplitudes are different. And then what? They have a phase difference of phi. That means this graph or this wave starts little later compared to the first one. Later compared to the first one. It is starting somewhere here. As a general case, no? They have a phase difference of phi. Phase difference of phi. So it is starting little late compared to the first one. Understood? It's a general case. Phi can be anything between 0 and 180. 0 and 180. Understood? So what we have done is, we have taken two waves. Y1 is the first wave. Displacement for the first wave is given by y1 is equal to A sine omega t. A is called the amplitude of the wave. Amplitude means what? The maximum height of the wave. Similar way, B sine omega t plus phi is another wave whose amplitude is B. Look at that, the amplitude is B. Amplitude is maximum height. And they are differing in phase by phi, an angle phi. That means second one starts phi later, an angle phi later compared to the first one. Now, when they join together, principle of superposition says what? The resultant wave is given by y is equal to y1 plus y2. You've seen this in school classes. Y is equal to y1 plus y2. So I can add these up. What am I getting then? The resultant amplitude is given by root of a square plus b square plus 2ab cos phi. Right. This is the first equation you have. Repeating one more time. We have two waves here. A sin omega t is the first wave. Second wave is b sin omega t plus phi. Right? The amplitudes are different. Here the amplitude is A. Here the amplitude is B. And even the phase angles are different. Here the phase angle is omega t. Here the phase angle is omega t plus phi. So they differ in phase by phi. And when they fall on each other, the resultant is given by y1 plus y2. And what is the resultant amplitude? Resultant amplitude, you would expect that to be A plus B. This is A, this is B. So resultant amplitude would be, logically it is A plus B. But that is wrong because phasor algebra is to be used. These involve phases, right? Phase angles. Phasor algebra you have learned in alternating currents. So it is to be treated like a vector. This is to be treated like vectors, no? These are to be treated like vectors. Understood? This is like a vector. This one is also like a vector. So when you add them up, you have to use parallelogram law of vector addition. It is what? Root of p square plus q square plus 2pq cos theta. So resultant of amplitudes is given by a square plus b square plus 2ab cos phi under root. And then what is the intensity? Resultant intensity. Resultant intensity is given by IA plus IB plus 2 root IA IB cos phi. You have done this derivation in school classes. So I won't elaborate on it. Just see the equation. That's it. Because intensity is what? Class 11. Intensity is defined as k into amplitude square. And when you put it over here, this value over here and solve it, simplify it, you're going to get this equation. I is equal to IA plus 2 root IA IB cos phi. Quick recap one more time. Interference. Interference is all about superposition. Two waves are joining together to give a resultant wave. Okay. So we take a general case here. We have taken two waves. First wave is this. Second wave is starting a little later, like phi angle later. So first wave can be represented by what? An equation. This is a simple harmonic equation for a simple harmonic motion or a wave function. Y is equal to a sin omega t. A is the amplitude. Omega is angular frequency, right? And then y2. I take another wave, y2, whose amplitude is different. It is b. And then the phase angle is also different. It is omega t plus phi. And when they join together, the resultant amplitude, contrary to your expectations, it is root of a square plus b square plus 2ab cos phi. And this is amplitude. And if you want to get intensity, intensity is ka square, k into amplitude square. Put this amplitude value over here, right, over here. And if you simplify it, you'll get this equation, IA plus IB plus 2 root IA IB cos phi. That means when two intensities, IA and IB, join together, one intensity is IA, second intensity is IB. When they join together, you expect the result to be IA plus IB. But there is a third term that is showing up, and this term is called interference factor, which is causing a beautiful phenomenon called interference. Okay. Now that happens with different waves, but we'll basically look at light waves in this chapter. Okay. So what is it again? I have two waves with intensities IA and IB. IA and IB. IA is what? Intensity of the first wave. IB is what? Intensity of second wave. Just give me 1 minute, please. IA is intensity of first wave. IB is intensity of second wave. So you would expect like the result to be IA plus IB. But instead what you're getting is IA plus IB plus 2 root IA IB cos phi, where phi is the phase difference. IA and IB are the intensities of the waves. And again, this is called interference factor, and it is causing the phenomenon of interference. Okay, so I is equal to IA plus IB plus 2 root IA IB cos phi. Did you understand this much? All right. So what is the equation for intensity? So far we have seen two equations. First equation was resultant amplitude is given by root of a square plus b square plus 2ab cos phi. This is the equation for resultant amplitude. Okay, when two waves join together, the resultant amplitude is given by root of a square plus b square plus 2ab cos phi. A is the amplitude of the first wave, b is the amplitude of the second wave, and phi is the phase difference. And then second point is intensity is given by IA plus IB plus 2 root IA IB into cos phi. That is our second equation. I'm going to give you a third equation now. What is the condition for maximum? If I want to get intensity maximum, tell me what? There is one variable here, cos phi. When is cos phi maximum? Cos phi can have a maximum value equal to 1. That would make what? I max I can write. I max is equal to what? I max is equal to IA plus IB plus 2 root IA IB. Right. In school, they might have taken this as I1 plus I2 plus 2 root I1 I2. Right. Okay, I'm taking it as IA plus IB plus 2 root IA IB because for maximum, this cos phi has to be 1. So if I put it over here, I'm going to get what? I max is equal to IA plus IB plus 2 root IA IB. And this looks like something you've seen so many times. This is a square plus b square plus 2ab, which is what? A plus b the whole square. A plus b the whole square. So root of IA plus root of IB the whole square. That is my equation for I max. Repeating one more time, the intensity equation is I is equal to IA plus IB plus 2 root IA IB cos phi. I want this intensity to be maximum. Maximum means bright band. Later on, you will see bright bands. That is called constructive superposition, where you have maximum. And what is minimum? Dark band or destructive superposition. So I might be referring like constructive superposition or bright band or bright fringe. There are many names for it. And then, or on the other hand, I have destructive superposition, dark band, dark fringe, minimum. Those are different names anyway. So I max is what? IA plus IB plus 2 root IA IB. So if I take it as square root of IA plus square root of IB the whole square, I'll get what? Same equation back. Similar way, what is I min? I minimum. I minimum can be calculated as, for minimum, cos phi should be what? Cos phi should be minus 1. Minimum value of cos is what? Minus 1. Cos 180 is minus 1. So it is minus 1. That would make this minus. So what do we get? IA plus IB. Then what? This becomes what? Cos phi is minus 1. When you multiply this with minus 1, it is 2 root IA IB. 2 root IA IB. And this looks like what? Again, something familiar to you. Root of IA minus root of IB the whole square. So this is I min. Yeah, that's right. I min. Okay. I max and I min. Now we have an important ratio. I max to I min. I max to I min. This is an important point. I max to I min. Even for the CBSE board examinations, this is important. I max to I min ratio. What is I max to I min ratio? Root of IA plus root of IB the whole square divided by root of IA minus root of IB the whole square. Right. This is the ratio of maximum to minimum intensities. Maximum and minimum intensities. And what is root of IA? IA, I told you it was taken as Ka square in the beginning. K into amplitude square. Intensity is what? Intensity is proportional to amplitude square. You've seen this many times in first year classes. Intensity is equal to constant into amplitude square. Similar way, intensity of second wave is what? Kb square. So what is root of IA? Root K into A. What is root of IB? Root K into B. So let's put them over here. So this is root K into A, root K into B, root K into A, root K into B. All the root K's are gone. And you're getting what? A plus B the whole square by A minus B the whole square. I divide everyone with B. A by B plus B by B is 1. The whole square by, this is A by B minus B by B is 1. The whole square. This A by B has a name R. This is called amplitude ratio. Ratio of amplitudes. A is amplitude of the first wave. B is amplitude of second wave. So that is the ratio of amplitudes. It is called amplitude ratio. R plus 1 the whole square over R minus 1 the whole square. Right. So this equation is important for school boards also. I'm repeating this. I got I max here. I max is root of I plus root of IB the whole square. I min is root of IA minus root of IB the whole square. We have the ratio I max to I min, which is root of IA plus root of IB the whole square by root of IA minus root of IB the whole square. What is IA? IA was taken as KA square. IB was taken as KB square. So root over IA will be root K into A. This is root K into B. So root K into A, root K into B, root K into A, root K into B. All root K's are taken common and cancelled. And then what? You're left with A plus B the whole square by A minus B the whole square. And if I divide throughout with B, I'm going to get what? This is A by B, this is B by B, B by B is 1. Again A by B minus B by B is 1, the whole square. A by B is called amplitude ratio. It is R plus 1 the whole square by R minus 1 the whole square. Did you understand? So we have seen Imax to Imin ratio. Now we have a couple of more points here. I'll tell you. Look at this. Later on, we'll see something called Young's double slit experiment. Young's double slit experiment. Thomas Young did this experiment on interference. I'll tell you. This is a source of light. I'll briefly explain the experiment. We'll come back to that later. Okay. And then there is a screen over here. And what do you see on the screen? You'll see uniform illumination on the screen. All right. This is uniform light on the screen. And then what? All of a sudden, if you bring in a pair of slits in front of this, slit means what? Cuts made using blade. Okay, these are cuts. And what will happen then? Light is coming out of this, light is coming out of this. They are joining either constructively or destructively based on conditions, creating a pattern on the screen. This is called Young's double slit experiment. All right, I'm repeating. Young put a source of light and then a screen at a distance. There was uniform illumination everywhere. The screen was evenly lit. The screen was evenly lighted up. And then there was illumination, uniform illumination on the screen. And when he brought a pair of slits in front of it, right? Slit means what? You take a paper and make a cut using a blade or a knife. Okay, they should be very narrow. And then what? Light is coming out of this, light is coming out of this. They are joining together. Or here, they are joining. Here, they are joining. Here, they are joining. Here. Everywhere they are joining. And as a result of this, what you see on the screen is a pattern called interference pattern. Interference pattern. This is called interference pattern. This is called interference pattern. The central band is always a bright band. Then we have a dark band, then bright, then dark, then bright, then dark, like this. Okay, right. This is what you see on the screen. Look at this. This is what you see on the screen. This is called a zeroth band, or zeroth maximum. Give me 1 minute. Okay, so this is zeroth band or zeroth brightness, central maximum. There are different names for it. Zeroth maximum. This is first dark, first bright, second dark, second bright, third dark. It goes on like that. Similar way here, first dark, first bright, second dark, second bright, third dark. Upwards also first dark, first bright, second dark, second bright, third dark. It goes on like that. Understood? These are called interference bands. We'll have a detailed discussion on this later. But I just wanted to know this. I wanted you to know this because, you know, we will see one equation involving the width of a slit now. Width of a slit. It's an important question. What happens if I open one slit more? Open one slit more. There will be more light coming out, right? So I could say width of a slit is proportional to intensity of light. Okay? Width of a slit. See, there are two slits here. There are two slits here, which are usually identical. If they are identical, this IA and IB are equal. In most of the cases, 99.99% of the cases, they won't give you IA and IB. So if that is not given, you could take both of them as I. Because the slits are identical, so same intensity of light will be coming out of the slits. Understood? Same light, you know, light coming out of this is IA, light coming out of this is IB, both will be I, if not specified otherwise. Sometimes they will give like, you know, IA is I and IB is 3I, or IA is 3I, IB is 9I. Understood? If not given specifically, you could take both of them as I, because both are identical in all cases. Understood? And then what if I open one slit more? It is obvious. Width of the slit is more means intensity is more. If I open it more light will come out of it. Right? So width is proportional to intensity. So width of A will be what? A constant into IA. I can remove the proportionality. So width of B will be what? A constant into IB. So I can take WA by WB. What is this? CIA by CIB. C and C are cut. IA was written as KA square in the beginning. IB was written as KB square. K and K are cut. So I got the equation WA by WB is equal to A square by B square. So A by B will be what? A by B will be square root of WA by WB. This is an important equation. Okay, you won't see this in textbook, but it's very, very important. I'll repeat one more time. This is an equation connecting width of a slit and amplitude. As you know, when you open a slit more light will come out. So you can have an equation here, width is more, intensity is more. Right, so width is directly proportional to intensity. Or width of a slit is equal to constant in intensity. So constant is C. Width of A is equal to C into IA. Width of slit B is equal to C into IB. Then WA by WB is equal to CIA by CIB. C and C are gone. IA by IB. IA is KA square. We learned at the beginning. IB is KB square. K's are also getting gone. Then what? K's are gone means you got A square by B square is equal to WA over WB. Then A by B will be root over WA by WB. This is the relation connecting slit to width and amplitude. Till this, you know, the topics are common for board examinations also, but the next equation is exclusive entrance examination point. Okay, that won't be asked in board examinations. This is called fringe visibility. Fringe visibility. Fringe visibility is given by Imax minus Imin divided by Imax plus Imin. Imax minus Imin by Imax plus Imin. Fringe visibility, just in case they ask. Okay, it's a previous question. Imax minus Imin by Imax plus Imin. Fringe visibility is maximum when fringe visibility is maximum when, if this is to be maximum, just give me 1 minute. Yes, if this is to be maximum, I'll tell you the condition. What is the condition? I minimum should be equal to 0. If I minimum is 0, this is gone, 0. This is gone, 0. Then I max by I max, that will be 1. 1 means 100% visibility. So you have 100% visibility when I minimum is 0. That means perfect destruction should be there for darkness. Actually, when you see this, this is not perfect dark in all cases. Perfect dark in all cases. This is bright and this is less bright. Less bright will be called dark. Understood? See, this is bright band and it is brightness for sure. This is dark. Even though we call it dark, it is not absolutely dark all the time. Why? Because just see this. Just see this. I have one wave here. I have another wave here. I have another wave here. Now see their superposition. This has a height of y1. This has a height of y2. They are going to destroy because one is going up, the other is going down. So they are going to destroy anyway, but not absolutely because they are not equal in height. Then what? Even in the end, you will have something left like this. But this is destruction. Why? Because this was going up. That was positive displacement. This was negative, right? They were out of phase and they were actually destroying each other. But even then, the destruction was not absolute. You still had something left. But even this could be called what? This could be called a minimum. But you have perfect destruction when, you know, both the heights are equal. Look at this. This height and this height are equal. What happens now? This is like y, this is like y minus y will be 0. That will be perfect darkness. So that is a condition for I minimum is equal to 0. Did you understand? See, what's happening here? Vmax, Imax minus Imin by Imax plus Imin is equal to fringe visibility. And fringe visibility is maximum under one condition. What is that condition? I minimum is 0. I minimum is 0. This is 0. This is 0. Imax by Imax is 1, which is 100%. And that is logically correct as well. You won't need physics for this. Why? The fringes are perfectly visible when this is perfectly dark. When it is perfectly dark, there will be a contrast between dark and bright. That is when the fringes are most clearly visible. Right. So visibility, it is correct. It is apt to say that visibility is 100% when the dark bands are perfectly dark. Understood? So there can be cases with less darkness. Understood? Less darkness for this. In that case, fringes won't be as visible as in this case. Understood? We have one more concept left here. I'll tell you. You know, I have a wave here. The wave is drawn like this. Okay. And I have a second wave that is starting over here. This point is 0. This is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. All right. 0, pi by 2, pi, 3 pi by 2, 2 pi. Now, the path difference between them is lambda. Right? In textbook, they have directly given this, but I'm just telling you how you get this equation. All right. So what is the path difference between the waves? This wave is starting over here, while this wave is starting here. Look at this line, this point, no? So what is the path difference between them? Path difference is lambda. Wavelength, one wave's length, right? This is called a crust and this is called trough. Crust and trough together make a wave. So length of this wave is called wavelength. So the distance between this point and this point, which are the starting points of these two waves, will be equal to lambda. So I could say that the path difference is lambda. Path difference is lambda. The corresponding phase difference is what? Corresponding phase difference. Phase difference is 2 pi, I would say. Why? This starts at 0, while this wave starts at 2 pi. The angle difference is 2 pi and the distance difference is lambda. Path difference lambda, corresponding to which you have a phase difference of 2 pi. Actually, you must have learned this in first year classes in waves. But in class 12, it is given directly. The equation is given directly. And this is how you get this. Just imagine you have two waves which are starting 2 pi apart. Look at this. This is starting at 0, pi by 2, pi, 3 pi by 2, 2 pi. Second one is starting at 2 pi. So this is starting at 0, while the second wave is starting at 2 pi. The angle difference between them is 2 pi. Angle difference is called phase difference. Phase difference is 2 pi. What about the path difference? Path difference is lambda. So whenever you have a path difference of lambda, corresponding phase difference is 2 pi. So if it is lambda by 2, it will be 2 pi by 2. It is lambda by 3, 2 pi by 3. Lambda by 4, 2 pi by 4. 2 lambda by 3, it is into 2 by 3. So whatever you put on the left side must be put on the right side as well. That's it. Corresponding to a path difference of lambda, the phase difference is 2 pi. This is an important point to be memorized. Otherwise, because they'll give you questions in lambda, in terms of lambda, but the equation has what? The equation has I is equal to IA plus IB plus 2 root IA IB cos phi. I'll tell you why we need this. Because in the equation we have, what we have is phi, phase difference. But when you measure it, it is path difference that you are measuring. That is easy to measure. Look at this. These are the paths. If you draw a perpendicular, this is the path difference. It is easier to measure. So you can measure the path difference and you can find the corresponding phase difference and you can put it in this equation. Because in the equation, what we need is phi. In the equation for interference, what we have is phase difference. Understood? But on the other hand, it is easier to measure path difference. So we measure the path difference here, and using this equation, you convert that to phase difference here and then put it over here. Understood? Section A, question number 1. Section A, based on interference. Two coherent, I'll tell you what coherent is. Two coherent monochromatic light beams of intensities I and 4I are superposed. The maximum and minimum possible intensities in the resulting beam are. It's a frequently asked question, many times asked. Same type of question has been asked many times. Two coherent monochromatic light beams of intensities I and 4I. So IA is given, it is I. Similar way, IB is given, it is 4I. Two monochromatic light beams of intensities I and 4I. So IA is equal to I, IB is equal to 4I. You got to find what? The maximum and minimum possible intensities. What is the equation for Imax? Imax is given by root of IA plus root of IB the whole square. That is what? It's an easy question. Root of IA plus root of IB the whole square. So let us put it over here. Root of I plus root of 4I the whole square. This is what? Root I plus root of 4I is what? 2 root I the whole square. 1 root I plus 2 root I is 3 root I. 3 root I square is 9 times I. And what about I minimum? I minimum is root of IA minus root of IB the whole square, if you remember. So it is root of IA is I minus root of IB is 4I the whole square, which is what? Root of I, this is root of I minus root 4 is 2, 2 root I the whole square. 1 root I minus 2 root I is what? Minus 1 root I. 1 root I minus 2 root I is minus 1 root I. Minus 1 root I square is I. So I max is 9I, I min is equal to I. Do you have that option? We have this in the options, 9I and I? Yes, answer is option C. Did you understand? A2. If the amplitude ratio of two sources producing interference is 3:5, the ratio of intensities at maxima and minima is. Amplitude ratio of two sources is given 3:5. Amplitude ratio is given. What is amplitude ratio? A by B is given 3/5. Amplitude ratio. It was called R. Right. We had a term for it. It was called R. Amplitude ratio is called R. It is A by B, which is 3/5. You've been asked to find I max to I min ratio. What is the equation for I max to I min? We wrote this equation A by B plus 1 the whole square by A by B minus 1 the whole square. You check the notes. A by B plus 1 the whole square by A by B minus 1. The question is to find out the ratio of maximum intensity to minimum intensity. So I max to I min is A by B plus 1 the whole square by A by B minus 1 the whole square. What is A by B? A by B is 3/5 plus 1 the whole square by 3/5 minus 1 the whole square. Right. So this is what? 5 goes here. 5 plus 3 is 8. 8/5 the whole square. Right. Divided by 5 goes here. 3 minus 5 minus 2/5 the whole square. So 5 and 5 are cut. 8 square is 64. Minus 2 square is 4. The answer is 16:1. Did you understand? Question number 3. In Young's double slit experiment, if the widths of the slits are in the ratio of 4:9, the ratio of intensity at maximum to minimum intensity at minimum will be. So what's the question? In Young's double slit experiment, if the widths of the slits are in the ratio of 4:9. Width ratio is not given in textbook, but I have given the equation here. Width ratio is given. Width of A by width of B is 4/9. Width ratio. What is the question? In a Young's double slit experiment, the widths of the slits are in the ratio 4:9. So widths are in the ratio 4:9. If I take this as what? Width ratio is what? WA by WB is, we wrote an equation for it, A square by B square, if you remember. Right. A square by B square is what? A square by B square is 4/9. Or if I take square root of this, A by B is 2/3. And the question is what? They have asked you to find the maximum to minimum intensity. I max to I min. I max to I min, we had a relation. I max to I min. It was what? A by B plus 1 the whole square by A by B minus 1 the whole square. Right. What is A by B? It is 2/3. Right. I can put it over here. So it is 2/3 plus 1 the whole square by 2/3 minus 1 the whole square. Tell me what you're going to get. This is 2/3 plus 1. 3 goes over here. 3 plus 2, 5. 5/3 the whole square by 3 goes here. 2 minus 3 is minus 1/3 the whole square. 3 and 3 are cut. 5 square is 25 and minus 1 square is 1. 25:1. Answer is 25:1. Option C. Did you get this? Read question number 4. Two beams of light having intensities I and 4I interfere to produce a fringe pattern on a screen. So there are two beams having intensities I and 4I. So IA is given as I, IB is given as 4I. Usually they won't be given. In such cases, you could take them as I and I. But here they have specifically given that IA is I, IB is 4I. So they are coming from different slits of different widths. Then interfere to produce a fringe pattern on the screen. Alternate bright, dark, bright, dark, bright, dark. The phase difference between the beams is pi/2 at a point A and pi at a point B. So there are 2 points you're looking at. This is the setup, source of light, the slits here, slit number 1, slit number 2, and this is 1 point. Okay. They have a phase difference and this is another point. They have certain other phase difference. And you're looking at 2 points here. This is A and this is B. All right. The phase difference between beams at A is pi/2 and at B is pi. The difference between the resultant intensities at A and B. I have to find the difference between intensities, right? So let us do at A first. At A. What is the phase difference? Phase difference is pi by 2 in the first case. So I can find intensity at A. What is this? Intensity at A is IA plus, that is I plus, IB plus, that is 4I, plus 2 root IA IB cos pi by 2. What have I written? I've just written the equation for intensity. Resultant interference. Resultant's equation. I is equal to IA plus IB plus 2 root IA IB cos phi. In case number 1, they say that phase difference is pi by 2. That is why I put pi by 2 here. But cos pi by 2 will vanish. It is 0. What do we get then? I plus 4I is 5I. This is IA, intensity at A. So I'm done with first part. Then second part at B. At B, what do they say about B? The phase difference there is not pi by 2, it is pi. So I can have another equation there. IB, intensity at B is what? IA plus IB is 4I plus 2 root IA IB into cos of pi. Phase difference is pi there, no? So it is what? I plus 4I is 5I. Then this is 2 into, plus 2 into 4I into I, 4I square. Square root of which is what? 2I into cos pi is minus 1. Cos 180 is minus 1. What do we have then? This is 5I, 2I into 2, 4I, minus 1, minus 4I. That is I. So you got IA, you got IB, right? Then what? What is the question? Find the difference in intensities. Find the difference in intensities at A and B. So I got to find the difference in intensities. IA minus IB. What is IA? Where is IA? 5I. 5I minus IB is I. That makes it 5I minus I is 4I. Did you understand? Question number 5. In a Young's double slit experiment, the intensity at a point, previous IEEE question, previous JE question. In a Young's double slit experiment, the intensity at a point where the path difference is lambda by 6. Path difference is lambda by 6 is I. So, in a Young's double slit experiment, the intensity at a point where the path difference is lambda by 6. See this? Path difference is lambda, phase difference is what? Phase difference is 2 pi. And they say that the path difference is lambda by 6, phase difference is 2 pi by 6. Path difference lambda corresponds to phase difference of 2 pi. As per the question, path difference is lambda by 6, which would make phase difference 2 pi by 6. This and this are cut, it is pi by 3. Keep that in mind. Let's come back and read the question again. Lambda being wavelength, okay, is I. Okay, if I0 denotes maximum intensity, then I by I0 is equal to. So first case I am writing I is equal to. I use a bigger I there, no, because there will be confusion between I on left side and I on right side. I is equal to I plus 2 root I into cos of pi by 3. Because in first case, they say that the phase difference is pi by 3. They haven't explicitly given it, but instead they have given the path difference lambda by 6, corresponding to which the phase difference is 2 pi by 6. So I'm finding the intensity at the first location. They have called it by the name I. I use a bigger I there. Bigger I is equal to I plus 2 root I into cos pi by 3. Why pi by 3? Because phi is pi by 3 there. So let us simplify this. I plus I is 2I plus this is 2 into root I into I cos pi by 3. Cos pi by 3 is cos 60, which is 1 by 2. Right? Oh, fine. 2 and 2 are cut. It is 2I plus I is 3I. So I got I now. Now they are talking about a maximum. This is my first equation. They are talking about a maximum there. Am I correct? If I0 denotes maximum intensity, so I am writing I0. I0 denotes maximum intensity. How do you find maximum? Root of IA plus root of IB the whole square. That is how you find the maximum. Intensity maximum is given by what? IA plus IB plus 2 root IA IB. That is root of IA plus root of IB the whole square. Maximum intensity, we wrote an equation for it, right? Root IA plus root IB the whole square. So root IA is I, root IB is I, the whole square. That makes it what? That makes it root I plus root I is 1 root I plus 1 root I is 2 root I the whole square, which is what? 4 times I. And the question is, this is equation number 2. Question is to find out I by I0 ratio. So equation number 1 by 2 implies what? I by I0. That is exactly the ratio they are asking you to find out. It is what? On the right side it is 3I, on the right side it is 4I. So if you cut them over here, you get 3 by 4. It's a repeated question. It's a previous JE question, but the question got repeated few more times. Did you understand this? So you can write heading Young's double slit experiment. Young's double slit experiment. I told you we have a source of light here, and then what? There is a screen on which there will be uniform illumination. And if you bring a pair of slits here, you will see what? Alternate bright and dark bands. Alternate bright and dark bands on the screen. And this pattern is known as interference pattern. All right. This is the source of light. Source of light here. There are two slits S1 and S2. And these slits are separated by a distance of small letter d. And the distance between slits and the screen is capital letter D. On the screen, there will be bands. Alternate bright, dark, bright, dark, bright, dark bands like this. Central band is always a maximum, a brightness. Then darkness, brightness, darkness like this. Brightness, darkness, brightness, darkness like this. Okay, central band is always a bright band and it is called zeroth band, zeroth maximum. Central band is called zeroth band or zeroth maximum. Then we have first dark, first bright, second dark, second bright, third dark, third bright. Downwards also first dark, first bright, second dark, second bright, third dark, third bright. Okay. Now this is called interference. These are called interference bands and the pattern is called interference pattern. And this phenomenon of interference is the reason for the colors on the wings of a butterfly and the colors on soft films and soft bubbles. Okay. That is the first point. Colors on soft films. Colors on soft film or bubble. Then wings of butterfly, wings of butterfly. What is the phenomenon? What is the principle of physics behind this? It's a previous question. Interference causes colors on the wings of a butterfly or colors on thin film or colors on soft bubble. Then second point is, even though the interference bands are straight lines, as you can see, on a closer observation, they are hyperbolic. This is very, very important. They look like hyperbola. Have you heard about hyperbolas? You know, they are slightly curved like this, hyperbolic. Now, this is an important point. It's a previous entrance examination question. You can expect this question in this year's board examination also, since you have MCQs, right? Hyperbolic. Again, you know, the interference bands are not actually on a rigorous treatment. You'll get what? You'll get hyperbolic fringes instead of straight line fringes. But for simplicity, we are going ahead with straight line fringes for calculations. But like I said, rigorous treatment will give you hyperbolic fringes. Or on a closer observation, closer look, you'll say that it is a hyperbolic. These are hyperbolic fringes. And the third point is the width of an interference band is given by lambda d by d. Width of an interference band. Lambda d by d. What is lambda? Wavelength of light used. What is capital letter D? Distance between slits and screen. What is small letter d? Distance between the slits. Okay. This is the width of a band, be it a dark band or a bright band. Both the interference bands, no, be it dark band or bright band, the width is the same. You have done this derivation in school classes. Beta is equal to lambda d by d. Then we have next point, underwater. If I immerse the whole setup in water or in a liquid, that's again a previous board question. The fringe width will be what? Lambda d by nd, because underwater lambda is lambda by n. Under a liquid, inside a liquid, lambda turns lambda by n, where n is refractive index. If I take lambda d by d together, it will be beta over n. Beta dash is equal to beta by n. That means the width of a band under a liquid, inside a liquid, is beta divided by n. Usually n value is always greater than 1. Most of the time it's greater than 1. So what happens then? When you divide with a number greater than 1, the value will decrease. So beta dash is always less than, beta dash is usually less than beta. Why? Because n is always greater than 1 most of the times. There is an exception, I'll tell you. Okay. And then the next point is distance from the center to nth bright band. Distance from center to nth bright band is n lambda d by d. Distance from center to nth dark band is 2n minus 1 into lambda d by 2d. I'm repeating the whole thing one more time. What is Young's double slit experiment? We have a source of light that illuminates a pair of slits. And like we've seen so far, these slits are cuts made using a blade. And then what? On the screen, you are seeing a pattern. Alternate bright and dark bands. Central band is always a bright band. You learn the reason for this in school. Central band is all the time, it is a bright band. It can never be a dark band. All other bands, this is first dark, first bright, second dark, second bright, third dark, third bright. Downwards, first dark, first bright, second dark, second bright, third dark, third bright. But all the bands, be it dark band or bright band, the width will be the same. Width is beta is equal to lambda d by d. Lambda is the light, wavelength of light used here. Capital D is the distance between slits and screen. Small d is distance between the slits. And then, like I said, colors on soft films or bubbles or wings of butterfly, they are due to interference of light. Some of the colors are gone. They undergo destructive interference. You see the rest of the colors. See, white light has violet, indigo, blue, green, yellow, orange, red. Some colors are undergoing destructive superposition. You are not seeing them anymore, which means what? You'll see the rest of the colors. Anyway, just know this, that's it. And the fringes are what? Fringes are, like I said, fringes are hyperbolic. They are not linear, they are hyperbolic. And then beta is lambda d by d. And if you immerse the whole setup of experiment inside a liquid, beta dash, the new width of the band is lambda d by nd, because d doesn't change, small d doesn't change, but lambda changes to lambda by n, because the refractive index is n there, no? And if I take lambda d by d together, that'll be what? That'll be beta. So it is beta by n. And like I said, most of the cases, n value will be greater than 1, which means what? When you divide with a number which is greater than 1, this value will decrease. So beta dash is always less than beta. So under a liquid or inside a liquid, the width of the band decreases, it gets narrower. Then distance from center to nth bright band. N is a number, it can be third bright band. So 3 lambda d by d. Seventh bright band, 7 lambda d by d. This is the question that's been asked most number of times, highest number of times. Distance to nth bright band, it is important for school boards, CBSE boards also. N lambda d by d. Distance to nth dark band is 2n minus 1 into lambda d by 2d. In school, they might give you 2n plus 1, but never ever take it, even though you are correct. Because you'll definitely land up in trouble. I'll tell you how it becomes a trouble for you. Anyway, 2n plus 1 is also correct, but there will be interference in counting. Anyway, it's better to use 2n minus 1 to lambda d by 2d. And I'll tell you a couple of more equations. This is an exclusive entrance examination point. I use a source of light here, 2 slits and screen. And when I use lambda 1 wavelength, I get n1 fringes. When I use lambda 2 wavelength, I get n2 fringes. What is the relation connecting them? n1 lambda 1 is equal to n2 lambda 2. Trust me, this is very, 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 very important. It's a previous IIT JEE question that got repeated later, okay? What is the question? I'm using a lighter wavelength lambda 1 here. Lighter wavelength lambda. For example, yellow light. Say I get n1 bands on the screen, n1 bands on the screen. And when I change the wavelength to lambda 2, some other color like indigo or blue or orange. I used blue or violet in the beginning, then I changed that to orange, lambda 2. Then obviously number of bands will change because width of a band depends on lambda, right? So probably more bands can be accommodated now. Anyway, just imagine n2 bands are there now. The relation between them is n1 lambda 1 equal to n2 lambda 2. Never ever forget this. They'll give you n1, they'll give you lambda 1, lambda 2, they'll ask you to find n2. Understood? They'll say like, with the 640 nanometer, say 18 fringes are observed. Then if the wavelength is changed to 720 nanometer, on the same screen, how many fringes can be seen? Or in the field of view, how many fringes can be seen? n1 lambda 1 equal to n2 lambda 2. Did you understand all these? So next one is an exclusive entrance examination point again. I'll tell you. I have Young's double slit experimental setup. And then I have a screen here. These are different beams. All right. I get a pattern on the screen. This distance is d. and this distance is small letter d, I'm going to introduce a thin film in the path of one of the beams. Okay, I got two beams here. Remember, this won't be asked in board examination, 100% sure. But for entrance, this is very, very important. So I got two beams here. This is top beam. This is bottom beam. And I'm going to introduce a thin film, soft film or glass film or mica film, like a transparent film in the path of one of the beams. What will happen to the pattern? The pattern will, as such, shift upwards or downwards. The pattern will shift as such upwards or downwards by a distance d by d into n minus 1 into t. It's an important point. D by d into n minus 1 into t, where capital D is the distance between the slits and the screen, small d is the distance between the slits, n is the refractive index of the film, t is the thickness of the film. Okay, now how do we know whether it is shifting up or down? When you introduce the film in the first beam, the path of first beam, it is shifting up. If you introduce that in the second beam, it will be shifting down. Anyway, the shift will be by the same distance. Y is equal to d by d into n minus 1 into t. All right, everything will be given. You just have to substitute and find out. But there is a problem. In some questions over the years, they've been asking it this way. They'll give the options in terms of number of fringes. I'll tell you how to get it. Look at this. I'm going to multiply this with lambda, or numerator and denominator. I multiplied with the lambda, I divided it with the lambda into n minus 1 into t. So if I take lambda d by d, it is what? Beta. So y is equal to beta by lambda into n minus 1 into t. I take beta to left hand side. Y by beta is 1 by lambda into n minus 1 into t. What is y by beta? Y is the distance through which the fringe system shifted, and beta is width of a band, and the ratio will be what? Number of fringes by which it has shifted. For example, you got 100 rupees in hand and one pen costs 2 rupees. How many pens can be bought? 100 divided by 2. Total cash available in hand divided by cost per pen. Similar way, total displacement by width of a band will give you the number of bands through which it has shifted. They will say like the answer will be like this: 2 fringes upward, 3 fringes upward, 2 fringes downward, 3 fringes downward. So you have to check for the options. In the options, if they have given it in meters or centimeters, you should use this equation. Okay. Or if in the options, if it is given in terms of number of fringes, you should be going for this equation. Understood? It will be easy to identify, because if this is the equation to be used, they won't give you capital D and small d, 100% sure. They'll instead give you lambda value. So if lambda is given, you better use this equation. Understood? Anyway, repeating one more time, we have an interference experimental setup. This is a source of light. There are 2 slits over here, which are separated by a distance of small letter d. And then there is a screen at a distance of capital letter D. What are we doing here? We are introducing a thin film. Film means glass film, soft film, mica film, whatever it is. It is a transparent film. What you do is, when you introduce a film, you are introducing an extra path difference there. There are calculations which are not to be learned at your levels. Understood? But anyway, just know that you are introducing a new path difference, extra additional path difference, which would make what? Which would make the whole setup move up or move down. The whole fringe pattern, the whole interference pattern will shift either up or down by a distance y. And that distance is given by what? D by d into n minus 1 into t. It can shift either up or down. When does it shift up? If you introduce it in the path of first beam, it shifts up. If you introduce it in the path of second beam, it shifts down. Understood? So anyway, it is d by d into n minus 1 into t. But this equation is to be used when the options are given in centimeters or meters. That means in distances. Y. Distances, y is distance, right? But in some cases, they can give it in terms of number of fringes. By how many fringes has the system shifted? Right. So y. What do you do for this? You multiply this with the lambda, divide this with the lambda. So lambda d by lambda d, right, into n minus 1 into t. What is lambda d by d? That is beta. Beta by lambda into n minus 1 to t. I take beta over to the left side. Y by beta is 1 by lambda into n minus 1 to t. N is the number of fringes. Y is what? Y is the distance. This is the distance. And beta is width of a band. So if you divide Y by beta, you are getting the number. Right, the number of fringes. In this equation, capital E is distance between them. Small d is distance between the slits. N is refractive index of the film. T is thickness of the film. Don't worry about anything. They'll give you all the values in the question. Did you understand this? T is thickness.